Morning, everyone. My name is Chris Paoli, editor, and I am pleased to be moderating our first session as well as welcoming you to our Enterprise AWS Cloud Security Summit, brought to you by SUSE and Lacework. The editorial staff of AWSinsider.net and Virtualization and Cloud Review have worked hard to bring together some of the best independent experts on this topic, so we really hope you enjoy it. Before we start today's event with these three great sessions, we do have some announcements. First, we want to let you know this event is being recorded and will be available for future viewings. You'll receive an email when the replay is available, generally within the next few days. Each of today's three sessions will be followed by a 5 to 10 minute Q&A. So please be sure to put your questions into the Q&A area of your console as they come up so we can get them answered for you. During today's third session, we will be giving away an espresso coffee maker, but you must be present to win. So be sure to stay on for the entire event. Finally, we do have resources from our sponsors, SUSE and Lacework, available on the console right now. So please download and check those out. It's because of SUSE and Lacework's underwriting of this content that we can bring you this summit. So we thank them for sponsoring and supporting the community and ask you to check out these resources so we can bring you more events like this in the future. Now on to the first session of today's summit, Threat Outlook. Top AWS Cloud Security Threats. This session features Ian Thornton-Trump, CISO at Cyjax. Ian Thornton-Trump, CD, is an ITIL certified IT professional with 25 years of experience in IT security and information technology. From 1989 to 1992, Ian served with the Canadian Forces Military Intelligence Branch. In 2002, he joined the CF Military Police Reserves and retired as a public affairs officer in 2013. After a year with the RCMP as a criminal intelligence analyst, Ian worked as a cybersecurity analyst and consultant for multinational insurance, banking, and regional healthcare verticals. Today, as Chief Information Security Officer for Cyjax Limited and Chief Technical Officer of Octopi Managed Services Incorporated, Ian has a deep experience with threats facing small, medium, and large enterprises businesses. His research and experience have made him a sought-after cybersecurity consultant specializing in building security operations, working as a VCISO, and sharing his passion for building effective cyber threat intelligence programs for enterprise organizations. Take it away, Ian.
All right, thank you so much, Chris, and a huge shout out to our producer, Kishana, who sorted us out, and of course our lovely host Melissa as well. So folks, this is me. I've been doing a lot of these AWS stuff, looking at the threats and looking at the threat landscape and things like that. So we're certainly going to get in there. And in fact, what I wanted to do is kick it off with a little bit of shock and awe. And this was really about a cyber intrusion that occurred with one of the main victims out of many victims, Capital One. And we know from the indictment that you see there on the left-hand side of your screen and this little extraction about how misconfiguration in the cloud was leveraged by P.H. Thompson, who essentially just collected data. Well, the data that she collected from Capital One happened to be credit card information. Now, interestingly enough, she was not a malicious actor in the sense of she collected all of this data, and that's contrary to the Computer Fraud and Abuse Act, and she was working for AWS at that particular time, so, but she didn't do anything with it. She didn't sell it. She didn't try and get rich with it. But this was the fallout. So she was indicted. She was found guilty. She was given a minimal sentence because I think, the judge realized that although she did, quote, harm, she didn't do harm to individuals, but she did great harm to Capital One, who, as I took the extract here, agreed to pay $80 million to settle federal bank regulators' claims that it lacked security measures because PH was able to send commands to the back end of a database that the firewall or the web application firewall misconfiguration allowed her to be able to do that in another customer's tenant. And then because of that, 80 million, which is essentially a fine from a bank regulator, that enabled a settlement of 190 million in class action suit. So to be fair, that was a lot of money. It's 270 million, excuse me. And we're in a situation now where this one cyber intrusion created a great deal of grief and consternation within AWS. Now, I wanted to start this off because it's really important for you to understand that we get sponsors in order to do these type of things, get me to talk at you. And the fact of the matter is AWS is a complex beast. There are a lot of things going on. There's a lot of features. There's a lot of complexity. And when you start talking about hybrid environments and you start talking about connecting on-premise data to the cloud, there are a number of potential got-is and problems. So I wanted to throw this up there as not so much P.H. Thompson threat actor who like to explore other people's networks, but as in the threat actor. And one of the big themes that you're going to take away from this is the threat actor may be you. And we'll talk about that as we get through. So a couple of really interesting things have kind of come out of my research on this particular one. So first of all, let's address AWS pricing. By far and away, AWS is less expensive than Azure. Okay. Now, AWS actually has lowered their price. I believe the number I was looking at was an astounding 67 times since AWS was first sort of brought into existence. Now, that's pretty impressive. But one of the challenges I think that really becomes difficult for businesses that are in the process of digital transformation is really understanding containerization, topics like microsegmentation versus monolith, which again I'm going to talk about in this presentation. But my sort of major understanding comes from the relationship between VMware and AWS services. So I wanted to zoom in here because this is what I actually have hands-on experience doing, okay? Now, and again, this is sort of where some really interesting security configuration magic can happen and some danger. So the idea that you can seamlessly shift workloads between vCenter servers within your own, I'm going to say data center, and move them to vCenter servers on AWS. The big caveat here is you have to have a big pipe in order to do this in any sort of like production level capacity. Because essentially what you're doing is you're moving virtual machines. And you're repopulating that virtual machine from your on-tenant premise onto your AWS environment. And then that opens up your opportunities where vCenter is actually sitting on top of and leveraging things like IS3, EC2, and then other types of capabilities, right, like Amazon Redshift and AWS Direct Connect, which is essentially, if I understand it, a private MPLS network that will layer on top of your networking connection into and give your data priority when you are using this kind of hybrid environment. Now, why do I make a big deal about this? Two major points to take away. So this is perfect world. This is the kind of thing where if you're talking about digital transformation and getting off old tin and moving to the fancy new cloud tin, this is an ideal scenario for that, right? And the amount of people that you can find that understand VMware, and I mean, to be fair, if I can understand how VMware works, you can understand how VMware works. But the idea here is that you can move seamlessly between the two environments, and I'll say a caveat on that. And by changing and updating DNS and or using load balancing technologies, you can essentially digitally transform, your infrastructure without worrying about the calls that go to possible services and databases that come back into your on-premise tenant, or by migrating them onto the AWS VMware cloud. You're now in a situation where you can again update your DNSs, and you can slowly digitally transform your infrastructure. Now, that does not in any way, shape, or form prevent a bunch of perimeter cybersecurity defenses that you have set up within your private tenant from being magically migrated into vCenter server, okay? Because at that particular point, it is quite possible, in order to make this all work, even though you've updated your DNS and you're now pointing into the VMware cloud, you may not have the infrastructure that you used to have, including reverse proxies and other types of security mitigations, and you can inadvertently expose your cloud services, the on-premise ones that were defended by your security infrastructure. You can expose them to the full terrors of the internet. So this is where security architecture of the AWS and leveraging AWS services becomes vitally important. Now, I wanted to link this back to our sponsors, because these type of operations are difficult, they're complex, and you need expertise. Can you learn all of these things? Yes, if you're given like 3 months and a test environment to do it, or you can really look at bringing in professional help to try and achieve your business goals. Now, I say this, remember, with the caveat that this is about where my comfort level ends, because I missed the boat on a few things that have happened in the AWS era, mostly because I've been sitting around thinking about threat actors and working in cyber threat intelligence. But this, I'm going to say hand grenade that David Heimer Hansen, and if you don't know who that is, look him up. He's the guy that invented the Ruby on Rails language, okay? He has some cred in the industry. Now, he did this blog post, and it was on LinkedIn and everything like that, and I included the link to the Amazon admission. And I think the key takeaway here is stay on top of the different technologies that Amazon offers, because it's critical to understanding when your distributed microsegmented architecture may no longer be suited. Now, I'm just going to say, a lot of folks are never going to be pumping out the amount of data that Prime Video, the Prime Video service, has on Amazon or Netflix, for instance. But what Amazon Prime Video team discovered was that the architectures that they originally designed in terms of like being able to deliver this video content, this HD content, ran into some hard caps in terms of the performance of Amazon infrastructure. And what's interesting is yes, you can throw more RAM, you can throw more compute, you can throw more storage to make it work, but it's one of those things where no matter how much you invest, your returns are limited, and this was because of architecture choices. So my first sort of threat actor scenario for you guys, or actually the second one after Piage and misconfigurations, is about understanding where your current architecture is and what its hard ceilings are in terms of scalability. Because if you do rapidly scale and you don't have the right architecture, as Prime Video will tell you in this amazing blog post, it's going to cost you a lot of money. And this is one thing that businesses are starting to scrutinize quite a bit, is the cloud spend. And I've read various reports suggesting that there's going to be a scale back of cloud spend. I don't see that. What I see is an optimization of cloud spend, and the idea that somehow by making radical changes in re-architecture, you can achieve that kind of gigantic cost savings. Now, let's be fair. This is Prime Video, so it's not like, they don't have, theoretically they have an unlimited budget because they are arguably one of the biggest cash cows for Amazon. But at the same time, everybody's billing everybody else internally within Amazon in order to find, how much the actual spend is. So I think that's important. So this is another sort of thing that's really interesting, is that by choosing this particular architecture, all of a sudden AWS, with its massive cost savings, can reduce pricing of its offering. Not that it would, because I think Jeff is pretty much a greedy guy. But the point here is that they are now suddenly way more competitive against older architecture that is in use by Netflix, that is doing video transcoding in separate engines instead of monolith. So I think this is actually really, really interesting. Netflix is using more than 100,000 server instances on AWS instead of very large, scalable servers that can meet the demand. Now, the thing in bold here is to take away is that Amazon has certifications, including a dedicated security one and dozens of free courses, not to mention a bunch of YouTube videos. This is an absolute key for your success. And I think I might even say it somewhere in the presentation, but if I don't, I'll say it now. You have no business playing in an Amazon production environment if you haven't done these certifications and haven't looked at it, for two very important reasons. The first is understanding all the different services that Amazon offers, and the second one is to know and develop a relationship with vendor partners that are experts in this field, because there are going to be things that you need to have a partner for in order to completely understand it. Of course, one of them is security, operations, and monitoring of performance, and those type of things that, unless you already have all of that network operations infrastructure set up, you really do need a partner to watch, help, and advise on everything from architecture to performance. Okay. Now, I want to talk a little bit about some threat actors that are consistently, and I mean in the case of folks that are breaking in to infrastructure to crypto mine, not generally launch a ransomware attack, but that is not unheard of within this space. But you are really dealing about some threat actors that go back at least 10 years now, right? And I think that's really important to understand, because when you're talking about groups like TNT and others, you're really talking about advanced persistent threat actors that not only are pivoting between espionage and, of course, traditional cyber attacks to mine cryptocurrency and or steal intellectual property from organizations, so a bit of both espionage and potentially ransomware attacks. But in general, these are the type of highly skilled cyber criminal operators. Now, in some cases, they're not skilled to the point of being able to launch zero-day attacks, but they can rapidly take proof of concepts that are dropped on Twitter or or reverse engineer patches and updates quickly to find opportunities to infiltrate other people's tenants. And this is why we talk about the importance of things like multi-factor authentication, certificates, management of access control lists in terms of what external IPs might actually be able to connect to that administrative infrastructure. But these folks are capable of exploiting Kubernetes, VMware, Docker APIs. So all of a sudden you are up against very sophisticated criminal threat actors. Now, this is what I really want to go through here in some detail so that you understand. Now, where it says Log4j vulnerable systems, insert any vulnerability, okay? Because this is really, really important to understand, is that the threat actor will be scanning for and looking at opportunities in the infrastructure to potentially exploit something in the front end, something in the F5 load balancing, something, a misconfiguration in the firewall, potentially accessing a cloud access key, potentially credentials, potentially a certificate that can be used for impersonation. Now, in Log4j, it was especially interesting because Log4j essentially made a connection to a library that was used in the Apache operating system, a library that could pass strings, which is ridiculous. But through this, it had the ability to make an outbound LDAP call out to the threat actor's malicious LDAP server, okay? And this is where things like firewalls, like Windows application firewalls, become critical in terms of defending against that. And this was a zero-day attack, by the way, that was originally dropped on a Chinese Minecraft server. And then, of course, it went global and the internet went on fire, and Kevin Beaumont tweeted that it was the end of the world as we know it, right? Not unlike some previous vulnerabilities that we've had. But the point is, if there is a new vulnerability in any of the supply chain infrastructure that you use, you know, such as the aforementioned VMware, but potentially a new one, hacker's going to hack. You absolutely have to pay attention to CISA's greatest gift, our America's Cyber Defense Agency's greatest gift to the world, which is the known exploited vulnerabilities catalog. This is a must subscribe to because you're going to need the kind of information that they're putting out there in order to defend your supply chain infrastructure when it comes to things that you put in the cloud, resources that you're using in the cloud, your cloud configuration, and all of these kind of things. Because otherwise what will happen is you will be a sad panda because you will get exploited rather quickly. It is very easy for an aggressive third party to set up a rogue server within Amazon's infrastructure to try and find all of these machines within the Amazon IP address range that are vulnerable to a potential exploit or zero-day attack. So, you know, think about that when you're considering your vulnerability management program and getting aggressive at both pen testing your development environments, which should be a mirror of your production environments. And we can talk about why I feel that pen testing production environments is a terrible idea. And that you should be pen testing either staging or development and never your production environments. But controversial, we can talk about that later. Now, I wanted to kind of point this out from a macro level in terms of the attackers, okay? So one of the things that actually struck me is that we've got more than a million active users in Amazon Web Services, but enterprise-scale customers make up only about 10%. With that, 90% of AWS users and the rest are small and medium businesses. Now, out of those small and medium businesses, you could include SaaS offerings that are built in AWS that have thousands of subscribers, of that SaaS offering. So when you think about the attack surface of AWS, it is very high on everybody's list because you're talking about small and medium-sized businesses majority in terms of the targets. So the question becomes, are they up to speed on the security and attack surface management of AWS? Do they know about all of the capabilities and or third-party software? At last count, some 7,000 plus data products and software listings in the AWS marketplace. And then again, in terms of like the types of services that you need, workload management, and of course, different databases built for different purposes. we're now back to architecture and understanding all of these offerings. So it's absolutely, I think, essential for business now to either be looking at that partner ecosystem and finding, especially in the small and medium-sized businesses, and finding the best way that they can defend their services that they might have migrated or moved online. Now, one of the things too here that I really need to illustrate here is there is a lot of value in just having the Amazon hosting environment for your business critical and mission critical services, basically because of DDoS attacks, right? DDoS, denial of service attacks, trying to knock your systems offline. It's a huge problem for businesses that are doing on-premise hosting, because the type the type of attacks that can be mounted now from bots, all of the world's filled with crappy video cameras that have been exploited and then turned into bots, and other types of equipment like firewalls can be used to create massive DDoS attacks. When inside the AWS environment, they offer protection against DDoS attacks. Outside that environment, you're going to have to deal with a third party or even your ISP as a separate service offering, and those, in fact, will have limitations as well. So I think it's really, really important to understand that the DDoS types of attacks that can be mounted against business critical systems are best defended in cloud services like AWS. Now, everyone's going to hit you with this. So I'm just going to walk through it a little bit very quickly so you can understand where AWS kind of cuts off and where you are responsible for. And I think the two areas that really, really focus on is the platform applications, identity and access management, and operating system, network, and firewall configurations. Not to mention the overall custodialship and protection of your customer data, right? But to be fair, that's more of a compliance concern than an operational IT ops. But I'm telling you right now, the focus and knowledge to do this successfully at AWS does not come cheaply, and it's mostly built on the tiers of people that have done things wrong in the past. So I really cannot stress this more, is that this is why you absolutely need to look at some of these AWS of the administrative courses before you have any purpose of touching an AWS infrastructure. With the caveat being, if you're using a third-party application such as Kubernetes or that VMware in the cloud offering, you can kind of fake it till you make it, but understand you may be exposing sensitive systems to the broader internet if you don't know what you're doing. And in order to gain an appreciation of this, anyone that really wants, I think, to be successful and have a base understanding of the cloud is really look at the CompTIA courses. They're inexpensive, they're comprehensive, they're worldwide recognized. I think it's really important to look at that. Yes, you can go out and you can get, a very expensive SANS course or something like that, or even a bespoke course around pen testing the cloud. But a basic understanding of the language and structure of how cloud services work is available from CompTIA. And I couldn't recommend that more if you're looking at making a move in your career to start down the road of, being able to understand cloud security and do cloud proper. Really, really great place to start. I just now want to pivot a little bit. So I made reference to this, but here you have it on my side. What is the number one AWS problem? Or rather, what is the number one AWS exploit? And that is folks using AWS don't know what they're doing. And that don't know what you're doing part is exactly where the threat actors attack. So it's you don't know what you're doing when it comes to credential management. You don't know what you don't know what you're doing when it comes to security groups and or access control lists. There should never be a or. It should always be an and, by the way. Both are required. You don't have, AWS Cloud Security Global SOC monitoring service, and, you're unsure about why you should adopt some of the AWS Cloud Marketplace security solutions. And what we end up with in a lot of cases, which makes it the most tempting attack surface for threat actors, is folks disable security to try and make stuff work. Now, fortunately, if you have Amazon Macie, you can discover some of that sensitive data at scale within your AWS tenant, or get some other third party that might be less expensive than Amazon Macie. But you can also look at Gray Hat Warfare, which is indexing all of the S3 buckets that are out there that are publicly accessible. And as you can see, there's a lot of publicly addressable buckets out there, and the number keeps growing. So despite my webinar and your attendance here today, I think what we need to do is take away and understand that even though we're talking about customer responsibilities, AWS has no responsibility to defend your storage, defend the compute, defend the database, or defend the networking from a hostile actor. That's on you. And again, if we come back to you don't know what you're doing, well, you kind of get what you deserve at that point. Now, I'm going to go through a bunch of AWS features here because I think it's really important to call them out because they do exist, but it might be a little difficult for you to understand exactly what they're offering because in digital transformation scenarios, you end up with a bunch of stuff spread out all over the place, right? So, you've got data in transit encryption. You've got your data at rest encryption capabilities. Again, in most cases, they're on by default, but in other cases, they need to be enabled, okay? And that's something that you need to research about how that's going to work. But before you enable any sort of encryption features, you certainly need to figure out how you're going to manage your keys. Now, whether or not that's your signing keys or software in a development environment, the keys for accessing particular resources or services that you have enabled encryption or encrypted communications, this is critical because if you lose your keys or your keys are compromised, that's it. You lose the show. And in some cases, you're going to have to do a complete rebuild of everything, or you're going to have to get a great third-party backup that connects via API to restore that data back to something new that you can secure with a new key. Trust me when I tell you, key management can be a real pain in the ass, and there are some organizations that are still doing this on an Excel spreadsheet, and I have no idea. They're just asking for absolute disaster. And it's a huge issue with leavers when somebody leaves the organization, maybe a senior developer or your head of DevOps, and they actually are the only one with the keys and access to the key management platform. So again, this comes down to your own sort of incompetence. Again, if you haven't figured out what the use cases were and how you're going to manage this, right? So we got other stuff, AWS Identity and Access Management. This is where you're going to do multi-factor authentication for your privileged accounts. In some cases, you're also going to use it for any user tenants that you have, et cetera, et cetera. And you can then use these capabilities in a bidirectional way with both Microsoft Active Directory for your existing Active Directory, but you can also use it for building, a federated access to even third-party stuff. So it's a really powerful tool, and it really helps you with figuring out how to manage accounts, but also do that single sign-on and guard privileged access. AWS Directory Services, very similar, but again, the single sign-on AWS SSO, I think, is absolutely critical, and it's shameful for organizations that are offering services in a cloud to not have AWS as SSO configured because they're essentially putting the data of their customers at risk for no other reason than what I'm going to call out as pure laziness, okay? These are the other sort of AWS things that you need, okay? So AWS CloudTrail AWS CloudWatch, and Amazon Guard Duty, okay? Or, sorry, Amazon CloudWatch. These are all services. Now, in most cases, they're going to be additional cost. And this is where we get into a lot of trouble. But, to be fair, you can really figure out a great way of, once you've figured out what your use cases are and what you actually need to monitor, you can go through that exercise and then you can find what the appropriate either third party is or the AWS service that you want to implement in order to help you. But this is where you need that architecture, that advice and counsel. In some instances, you're going to want to roll this all up into a SIEM solution, because what you really need is to understand when bad things are happening, and then this opens up the door. If once you've got it, in a SIEM, you can then look at security orchestration and response. These type of things become really interesting, especially when you're running instances and you want to feed in EDR and stuff like that. So I think it's really important for folks to look at their use cases in particular and explore the native services, but also look for more value from some of those 7,000 vendors that are in the Amazon stack. Okay, I'm going to pivot a little bit here that AWS is got, of course, holes. I mean, we saw the Dyn DNS attack that, that took out a bunch of DNS stuff for Amazon, and the East Coast disappeared for a little while. That was not good. That happened a number of years ago with the Myra botnet. But then you've got other mistakes that can be made, issues around certificate expiries. All of these things are sort of like a hazard of life. And a couple of things I want to point out here. It can happen to your on-premise infrastructure. It can happen in the cloud infrastructure. But one of the things Amazon does offer is this multi-regional approach. They're building data centers like crazy in all sorts of parts of globes in the world. So if you look at another geographic area, so for instance, when the East Coast of the United States went down because of an Amazon outage, many folks had hot standby or data replication going to the West Coast of the United States, and we're able, again, to either changes in DNS or load balancing technology, have that West Coast come online. And, once DNS had permeated out, you were essentially back in business. And if you're running load balancing across two instances, which you can do in AWS and other cloud services, you now have the ability to essentially take one down for maintenance and bring it back up while the other one takes over for those critical applications or for revenue generation purposes. But again, this will cost you. And it's really important that you understand, how critical is the services that you're offering your business, because not everything has to be multi-regionally redundant, okay? Now, a lot of folks ask me, and this is sort of now getting down to where we're going to sit for Q&A in a few short moments here, but the path forward is really about DevOps, DevSecOps, and cyber threat intelligence, okay? Now, yeah, I'm a little bit prejudiced because I think everyone should be intelligence-led, because if you're not intelligence-led, the default is you're being led stupidly. But that aside, let's really talk about the fact that you've got a situation here where your application is poorly architected to begin with or vulnerable. No matter if it's on-premise or in the cloud, it's still going to potentially be vulnerable unless it's the compensating controls that you've deployed in front of it. And I think that is a really, really important factor to understand, that in the process of digital transformation, if you had intrusion detection set up, if you had logging in the on-premise world, if you had specifically locked down certain services on that particular box, when it's moved up into the cloud, there could be dependencies that turn on those services. There could be situations where you're going to be exposed because you've lost that initial capability that you had when it was in your own on-premise data center. So these things have to be kept in mind. And I strongly consider, or if you like my candor, you must have Amazon certifications for DevOps, security, and architecture. You can't expect an IT on-premise team that has spent most of their life securing an on-premise environment to suddenly sprout cloud skills, okay? If you're a manager or a CISO or a head of cybersecurity or IT delivery, you absolutely must gain competence before you're told you have to. And this is one of the big arguments that ends up in organizations is like, do not eliminate the training budget because you'll take your precious databases and your precious front ends, put them in the cloud, and there will be nobody there that understands what they should be looking for from a security perspective or even a performance perspective, right? Ensure staging and dev are as close to or scaled versions of prod. And again, I say avoid pen testing production environments. Amazon, even though Amazon now says, hey, pen test away, we don't care. I think it's a terrible idea. And basically it's because if in the course of the pen test you knock something over, well, you've knocked production down. But in the case of pen testing a dev or staging environment that is scaled like production, then perhaps you can maybe get in front of it and not let that happen in your production environment. And chances are when production goes down, everybody from the senior vice president of vice presidents will be calling you about why the web server is down. And that's a little thing. You should look that up on YouTube because it's pretty hilarious and it's the world that we live in. So again, some top tips. Content delivery networks and web application firewalls in front of production are the way to go with web apps. There's no question about that. Understand what the threat actors are and what they are looking for, and it's about credentials, it's about exposed vulnerabilities. That's sort of the game right there. MFA controls, mandatory, even for customer data now. Like everybody's got to do MFA for banking in Europe. It just makes sense if you're talking about sensitive information for customers to protect it with MFA and make them deliberately turn it off if they do. That way you have plausible deniability and say, well, we gave you the security feature, you disabled it. We feel really bad about what just happened. Integrity monitoring and vulnerability scanning. I really like the idea of continuous vulnerability scanning now, especially in massive exposed enterprise facing internet exposed enterprise level applications. It just seems to make sense rather than, the monthly scan followed by, inaction within your organization and barely able to patch something in 90 days or even longer, as we find out when we do some of the post-game analysis of data breaches. And then sort of finally, look at obfuscating the data in the dev environment. If you do have less permissions in a dev environment, then it's really important that you don't put your your production data there. So sanitize that out. And again, DRBCP testing, look to a third party, look to something that has API integration into your AWS environment. I think it's super, super important to look at that because, if you are needing that, 24/7 availability, you're going to have to bite the bullet and look at multi-regional deployment for sure. Again, play the vendor game. Use the security features provided by Amazon, but as I love to say, work with partners like our sponsors, discover the better, the newer, and the less expensive. This is huge due to the level of complexity that you find in the AWS environment. And one of the reasons why you really need to reach out to vendors and stuff like that and build sort of a networking opportunity, where cloud services are part of the discussion, is really to have some folks to talk to. right? The best way to get the best Amazon Web Services advice is to talk to someone that knows what they're doing. And I think that's critical. And just to sort of reinforce the issue now before we go to our Q&A, if you're using the same set of credentials in the cloud for dev, staging, and prod, well, quite frankly, you may already find yourself walking in the fields of Elysium because you're already dead. And, Roy Batty, the CISO here, has some good advice here that malicious actors will destroy all three environments in moments if you don't secure them with a set of multi-factor authenticated credentials for each environment with some controls so that no one person has access to all of those things. That is a best practice. And now you have my attention for some Q&A.
All right. Yeah, let's jump right into it. Great talk. All right, first question comes in from Eugene. Do you have any perspective on API anomaly detection security similar to SEIM?
Yeah,
SIM,
definitely.
sorry.
Yeah, so API security is a huge topic. And one of the really interesting things is one of our analysts has got a paper he's going to be speaking on, hopefully at DEF CON or B-Sides Las Vegas, on API security. The only thing we can really do right now is look at API security from a perspective of access control. So what IP addresses, what domains are sort of okay to access. Make sure that our functions are well documented on that particular API, unlike using some Facebook technology that's basically steals all the personal private data of everyone using it, and then logging it and throwing that into a SIEM. And unfortunately, and this is sort of the big gap, is that when you really look at the attack surface management, a lot of the advanced persistent threat actors are pivoting now to APIs that have been poorly secured, not using best practices. In some cases, I know, God forbid, passing credentials. Now, just today, GitHub indicated that they're blocking anything that looks like a credential and any key by default. That's a really, really good thing. But unfortunately, some folks are still passing credentials inside an API, in some cases unencrypted, if you can believe it. So this is a really important area of security. I sort of say, once you've done all the basics, now move over to the development team and help them develop more securely. Okay.
Next question. Somebody in our audience is giving you a little pushback on something you said earlier today. Pretty controversial to not pen test production. Walk me through your thinking on this point, please.
Okay, so one of the things that I found here is that your production in a lot of enterprise environments is the most defended thing. So you might have that CDN, that web application firewall there. The problem is the pen testing company will want you to disable those in order to be able to get at the actual front end, right? Because Cloudflare will block a bunch of this crazy stuff that you're trying to do, your web application firewall, and if there's reverse proxy architectures involved there, like it's really, really hard to touch a actual production environment that is heavily defended, because the actual vulnerabilities then may never be detected even though they exist. So what happens is this: you get a false sense of security of the production environment because at that particular moment, your pen testing company is not throwing zero-day attacks at any of your infrastructure. My thing is secure from the ground up, right? The idea being is take a stab at dev and see what you can get out of dev that doesn't have all of those defenses in front of it. Then maybe look and see what you can do to fix the production environment, having the results from the dev environment to reduce the risk of having the pen testing company accidentally knock over your organization because they found something, right? And I know it's not a super likely occurrence, But I don't want to get, pulled onto the executive carpet and yelled at by the heads of sales because we were down for 3 hours when it was a self-inflicted gunshot wound to the head, right? I'd rather get in front of it, work with the developers, show them, the kind of things that are vulnerable in the system, argue that we have mitigation controls in effect, but, we could exfiltrate data if there was a vulnerability found in a library. Like, the whole issue with Log4j wasn't the fact that you could exploit it remotely and get all of that data out. It was the fact that there was no exfil on your own organization that allowed LDAP calls to come out of your organization to somebody else's LDAP server, right? So it was one of those moments where we just kind of dropped the ball. And actually, in a lot of ways, it wasn't only a fumble, it was a hand it to the wrong guy on the wrong team, right? So this is where I get pretty passionate about the idea. Now, if you're solid and you believe that the best representation of the security of the code that you've got pushed into production can be achieved by a pen test, have at it. I've just seen too many shaky things that I get pretty nervous when you fire up Zap and you go, yeah, ultimate, scanning, ultimate web attack mode. And I get a bit nervous that my next phone call is going to be from a VP somewhere.
We got a couple of recommendation questions. First one comes from Thomas. Do you have any suggestions for encouraging others to stay ahead on their cloud training?
Yeah, absolutely. So attend those lectures, attend things that are like new tools that are coming out to deal with specific business use cases, network at a couple of cloud security conferences, and just participate in that community, Twitter, Blue Sky, Mastodon, if kids are still going there, I'm not sure. LinkedIn, there's a lot of good things out there to stay on top of it. And there's good bloggers as well that are continually talking about it. And not to mention all the great resources that Enterprise AWS Cloud Security has and all of the downloadable content that some of our vendors always provide us with. So there's great ways. And, thanks for coming to this one because I hope you got at least a couple of interesting ideas out of it.
And then, what are some of your favorite tools for web application testing?
Oh, yeah, man. I'm old school. Zap and some of the stuff that's in Kali, I still adore SQL Map and what it can do to expose databases. But, that whole kind of like background is really about where I came from. And now I'm sort of working at more of an executive level and advisory level as a consultant in the vCISO role. And the folks that are coming up today, right now, the hottest thing you can be is a cloud security architect with 5 years of demonstrable experience and some certs. And in London right now, I think you're billing at close to £1,000 a day. So in US dollars, that's about 1,250 a day. So this is where you as a leader in the space have to surround yourself with people that have a passion for learning, that you've made the argument that they need a little test environment in order to look at this new technology and see what it's like. They have a development or staging environment where they can run proof of concepts with other vendors' offerings to really see if it's going to solve some of the business problems that you might be faced with.
Okay, let's get one more question in. If you're considering zero trust, I thought you needed micro-segmentation. Do you have any thoughts on zero trust and other architectures such as traditional VMs in the hosted in the cloud?
Yeah, definitely. So this comes down to like the three tenets, if you will, right? Not the three tenors, that's something else. But the three tenets of zero trust, which is the visibility piece, right? The automation piece and the orchestration piece. And what you need to do there is you need to look at solutions specific for the particular use cases that you're using. Now, in the case of where you've like basically migrated off of your tin and you put your servers up into the cloud, there's lots of hook-ins that you can do there with Azure Sentinel, collecting the logs, throwing that into a third-party SIEM or something like that in order to get situational awareness. The other big thing is to look at what your edge is going to be and what kind of edge technology are you going to put there, because that has a lot to do with defending the backend. Because let's face it, in those type of environments, there's going to be 2012 boxes there. God forbid, there's probably even 2008 boxes there. There's going to be a lot of stuff that's either end of life cycle, legacy. It's hooked in really weird ways. Okay, I'm going to say a word. It's a bit of a swear word in the industry now. It's called an INI file. And if any of you know what I'm talking about, there is literally we're running applications in the cloud where the INI file has to have global read-write access, and it's a giant security hole, right? So I think, to make a long story short, figure out, what the most vulnerable is. Look at all the different ways you can protect it, monitor it, restore it, and back it up, especially that data.
Okay, that's all the time we have for our first session. Thanks for the great presentation, Ian.
Oh, you're very welcome. It was my pleasure today.
Okay, welcome back, everyone. I'm David Rammel, editor of Virtualization Cloud Review, here to moderate the second session, Top 10 Modern AWS Cloud Security Best Practices of today's three-session event, which is being brought to you by the fine folks. Our speaker for this session is Stephen Smiley, an AWS ambassador and consulting director with ScaleSec, a security-first cloud consulting partner that helps enterprises create or enhance cloud programs through cloud security strategy and hands-on architecture, implementation, automation, and integration services. Stephen, it's great to have you here. Please take it away.
Great. Thank you so much for having me today. This is a topic that's near and dear to my heart. As a cloud security consultant, I think all day about what are the best practices that I want to implement, what things do I want to recommend to others, right? And really, how can I make these accessible and not something that's so abstract or so detailed that it's difficult to actually implement in your own world, right? So I work at ScaleSec, and we do cloud security assessments. We help you build security and compliance programs. One of our most common activities is helping you build a landing zone so that you can start off right in the cloud, or build secure engineering foundations, right? So if you're adopting new practices like infrastructure as code and CI/CD, we can help you do that right from the start. And so with that, let's jump into what are the top 10 things that I help people with, and that I think people kind of need to be doing more and more of in the cloud, in specifically in AWS. So I've got 10 of these. It's a lot of content, but my goal here is to make this really accessible to you. Please let me know if you have any questions. I'd love to help, and I'd love to help you. If you've got specific challenges, let me know. Let's bring it up, and let's hash it out as best we can. So the first one that I have been talking more and more about lately is organizations defining a cloud operating model. And in short, an operating model for your organization describes what are the teams that we're going to have, what are their responsibilities going to be, and how will they interact with each other, right? So rather than having deep silos where work is getting passed across each other and people are losing context, or a big open blob where nobody knows what they're doing, I think it's worthwhile to sit down and define your operating model. Specifically in the cloud, you want as much as possible to have teams that are aligned to some value stream that can be in touch with their customers and they're empowered. That's something the cloud provides that other platforms have not done as well at providing. So the cloud can help you define a team that can work mostly autonomously. They're also going to be enabled by some other teams. That might be something like a cloud business office that helps them, helps facilitate them working on issues. Your stream-aligned teams may collaborate with teams that are focused on a complicated subsystem, like dealing with sensitive data, like payment card data, something like that. And then generally they should be supported by some sort of platform team that's taking a focus on the cloud platform and thinking about what kind of capabilities can they provide to your stream-aligned teams, your product or service teams, to help empower them and take some burden off of them. So this is going to look a little bit differently for every organization, but I think it's really worthwhile to sit down and define, how are we going to operate? For example, you might say that your platform is going to be very heavily focused on Kubernetes, and you are going to deploy things with a particular log management platform and a particular security, incident and event management system. And, teams within the platform team provide those services, and people are required to use those. Or you may say, we don't want to use Kubernetes. We're going to go heavy on AWS Lambda and serverless things, or something like that. But at the end of the day, you should be defining how you want to take advantage of the cloud for your business purposes. Okay. So one of the things that you're going to start getting into when you think about the AWS platform is your network topology. And this is something that if you don't plan for it up front, you're going to run into issues, especially as you're trying to expand or manage or secure your network. And so I think it's really worthwhile up front to have a network plan. And this is something that we've done on-prem for a long time, so this is pretty familiar. But there's cloud specifics that you really want to consider. AWS provides an IP address manager that I think is worthwhile to use and can keep track of the IP ranges that you're using in various regions. And then it'll also see if you've got overlapping ranges or something like that. But more importantly is it'll prevent those, because you can kind of define a pool. And then when you make a new VPC, you don't actually specify the CIDR block. You can just specify, I want to pull from this pool, and it will give you an appropriate range. And so that just helps you prevent a lot of issues and make management easier. One of the other patterns that I've been advocating for recently is using shared VPCs over a model of many VPCs. So specifically in AWS, a VPC belongs in a specific region. So if you operate in multiple regions, you may need a VPC in each region. But you can share those VPCs, or specifically you can share subnets across accounts even, and kind of vend out subnets to teams and say, you will place your resources in this subnet, and you don't have to manage the network. You can kind of take that burden off of them. And then you can provide some central services there. So for example, you can provide a firewall, a central firewall for all that will inspect all egress traffic, for example. You may provide central NAT gateways and say, right, like all internet traffic is going to route through this. But also VPC endpoints. So in AWS, VPC endpoints can provide private access to AWS services like S3 or Systems Manager, or there's many things that you may want to access privately rather than going out to the internet. And you could just create them in one kind of central subnet, and everybody gets to benefit from those, and they don't have to figure out how to manage them themselves. So this is a pattern that I have been strongly advocating for. I've been using it with my customers and seeing a lot of success, especially when compared to the model of using Transit Gateway to connect a number of VPCs. That has been giving people a lot of burden. So that's something that you want to plan out for your requirements. Another practice that I strongly recommend is building and deploying with code. And obviously, this is something that has been established as best practice for a long time, but I still see people struggle to do it correctly, and so I think we still need to advocate for this. It's okay to build some test workloads in a sandbox account and click around in the AWS console to see what the right way, how you want to build something or how you want to use a service. But when it comes time to build something in production, to do it safely and reliably, you really need to pick some tool, whether that's CloudFormation or Terraform or something else related, and come up with a way that you're going to deploy it. Obviously, AWS provides some services like code pipeline and code build, and they have totally competent services. But you may elect to use, GitHub Actions or GitLab or whatever you prefer. But you should have this. This should be part of your platform plan. How are we going to build and deploy our workloads through code? The main benefits that you'll see with this is improved collaboration. Right? People can propose changes, and somebody else can review them and audit them and approve them. But also, it maintains a history, and it provides the mechanism for rollback. When something happens, you can just roll back to the previous version, and overall increases accountability. When it comes time to establish compliance, this is going to help a ton, right? If you need SOC 2 compliance or PCI or something like that, they're going to come and ask for a canonical version of what are you deploying and what's there and what's the history of changes and how are you gating changes to production. This solves all of those problems up front. And so if you have any specific questions about how to approach that for your environment, I'm happy to help. But this is something that you need to be thinking about. Another best practice that this one is I would say more emerging than others. But I think that this is something that's really exciting and important and definitely where the cloud is going. And that is building access, request, and approval workflows. So for the most part, what I observe is when people need access, they email somebody and they say, hey, I need something. And the person that's approving it and actually giving them access, they have no idea whether or not that person really needs access. They have no idea how to give them least privilege. What are the least privileges that they require, right? And then also from the requester perspective, you may not even know what you need. I don't know what's out there. I don't know what accounts are out there. And so something a platform team can be doing is building access, request, and approval workflows. I put on the screen here some of the tools that I've been seeing evolving in this space. Common Fate provides a open source tool for this, as well as a cloud platform. SimOps provides a tool for this. And there are some others that are evolving. I know that like Okta has a access workflow service. But ultimately, you want to be thinking about how can I make this discoverable and secure, and then make that access time-based, right? So for example, you can make a request that says, hey, I need this for just 1 hour. I'm going to go do this task, and then it's going to close. And then you've just really limited the risk of that access being exposed. You've removed any permanent credentials from being out there so they can't accidentally get leaked somewhere. And then, if somebody's endpoint, laptop endpoint is compromised, there's a much reduced risk to those credentials locally being used, being misused by an attacker. So this is something that I think we should all be thinking about. I am excited to see the tools evolve here, and this is where we're going. So let's think about how to do this better. Another best practice I think people really underutilize is Systems Manager, and there are many aspects to Systems Manager. The ones that tend to be the most useful are accessing an instance remotely through Session Manager, right? Like being able to SSH or remote desktop in. And that's great. Of course, we still want to avoid using that as much as possible, but if you are going to do it, Systems Manager lets you do it without even opening those ports, right? So it does it in a more secure way. But also Patch Manager, right? So we should be configuring patch management for any of our long-running instances, or even if they're short-running, we can have them automatically register with Systems Manager, and we can just see, hey, do these need critical patches? Systems Manager gives you the ability to get a dashboard of compliance for your patches and generally for the state that you want your instances in. And that's something that I don't think is used enough. Systems Manager also gives you the ability to run a command against a particular target. So if you want to run a PowerShell script or some sort of bash script, you can just execute that through AWS rather than logging in and having an active session against it. And then there's tons of benefits to this, like you've secured the access to that, who did it, and what the outcome was, and it's all stored in AWS. And almost all of these capabilities come without any extra cost, which is pretty sweet. I also wanted to highlight that one of the new capabilities in Systems Manager is the ability to turn on a default host management configuration. So rather than needing the correct permissions, which is what we used to do, and that's one of the big hangups was making sure that they had the appropriate instance role, you can now do it just through kind of a one-click setup and make it much easier to manage all your instances here. So if this is not something that you're making good use of now and you run a bunch of EC2 instances, then definitely look into its capabilities and see how you can take advantage of it. So moving on, the next best practice I want to highlight is segmented and immutable backups. Backups are important for so many reasons. And really what we want to be asking ourselves is, like, how are we going to protect our important data from destructive activity? That activity might be a malicious insider, it might be somebody who compromises our environment, but in general, man, if all of my important data gets deleted and I can't restore it in a reasonable amount of time. So think about how I'm going to segment my backups, even from my own people, and make them immutable so that even my own people can't delete them if they wanted to, right? So AWS Backup is the service that AWS provides for this. It has cross-account backup that you can enable, and it allows you to create a delegated administrator account so that you can designate particular people to manage your backup plans. And then those backup plans are available in whatever accounts you want them to be available in. So those plans are going to specify like retention periods and where the data is backed up and for how long. And then you can configure those plans to match on resource tags or other characteristics across all of your accounts. So it's worthwhile to set up a dedicated backup account where you make those plans, you store those vaults, and you protect the vault. To protect the vault, there's a couple things we want to be thinking about. One is the policy that's applied on the vault, because even if somebody has administrator, they will need to be permitted by the vault access policy to do any actions on those backups. So you want to carefully lock that down. And then service control policies, which would apply to all the accounts where you're restricting who can make changes to backup plans and backup vaults. So in combination, those two things, both resource-based and identity-based, can help you protect your vaults from unwanted destructive actions. And then one of the other features to be aware of and to consider is the backup vault lock capability. So this is one that's optional that you can turn on if you want to set a minimum and maximum retention period. But once this locks in like compliance mode, nobody can delete it, not even AWS itself, right? So this is something that you can use if you have really strict requirements and you really want to carefully make sure that that data does not get deleted. And then the last consideration of your backups is that you should have some alerts set up on any actions that you consider risky or that you just really want to be aware of. So in particular, if somebody makes a change to your backup plan or vault, you want to get a notification about that. You want to get a notification if somebody initiates a restore action, maybe from particular vaults. You might have a vault that's for day-to-day restores and you're not super worried about it, but you may have others that's like, okay, if someone's restoring from this, we definitely want a notification. And you can set those up through EventBridge and make sure that you get a notification on those so that you can notice if there's anything off. Okay, in that same vein, we want to be thinking in general about risk alerts, right? How will we know if risky actions are taken? So we talked about changes to backup, but other risks that you want to be considering are things like budgets. Like, what happens if we suddenly run up a big bill? I want an alert for that, right? And AWS provides the ability for you to set your own budget or even opt into cost anomaly detection. Those can be really helpful for detecting not just security issues, but I mean, definitely security. Someone spins up a bunch of instances, it's going to be expensive overnight. But also just incidental, like you've got people that are building stuff that maybe they don't know what they're doing. You want to know about those costs sooner rather than later. If you go to AWS and plead for them to give you money back because you made some expensive mistakes, they are going to ask you, did you have a budget set up, right? What controls do you have in place to prevent this? And so that'll help you a lot in being prepared for expensive cloud costs. Other risk alerts you probably want to set are things that are expensive or have long-term effects. So subscribing to something in the marketplace or creating a savings plan where you're committing to spend, right? Purchasing reserved instances, again, committing to spend, locking backups, or, right, because an attacker could potentially make you spend a lot of money by locking backups that you don't want, right? Or locking objects that you don't want to keep around, and now you have to pay for that. So those are risks that you want to be aware of. And then any other risky events like actions taken by my root user or things that are changing to my logging configuration through CloudTrail, stop logging, deleting the trail, creating IAM users, right? Most of us are using single sign-on now, so we don't use IAM users. So if someone creates one, that's suspicious to me. If someone deletes one that we have for some exceptional purpose, that is suspicious to me. I want to know why that. I want to know what happened there. Deleting virtual MFA device or deactivating MFA devices. I want to know about that. Access denied or unauthorized operation. That's not necessarily a problem, but that indicates that somebody is trying to do something outside of their permissions, and we should revisit that, right? Or failed console logins. Is somebody targeting me? Do they think they have a correct password? I want to know about that. So many of these things you can just block and say, with a service control policy, for example, I don't want anybody to be able to do them. But if they do come through, then I definitely want a risk alert, especially if I thought I was blocking them and now they've succeeded. Okay, so we talked about basic alerts, but how will we be thinking about some of the more advanced use cases, things where I don't necessarily have the ability to write a simple detection for this? Well, that's where Amazon has the Guard Duty service, right? So it's an intelligent threat detection service based on their intel and what they can see by looking at DNS logs, VPC flow logs, and CloudTrail alerts with a little bit of secret sauce sprinkled in from AWS. So I do think that we should be using Guard Duty, especially with accounts that are sensitive. But what I see way too often is that nobody's looking at these findings. Nobody's tuning these alerts. So if they get a false positive, they just let it go. And there's no value in that, right? If a finding happened, but nobody looked at it, it didn't help, right? So you need to, in your cloud operating model, designate who is responsible for investigating these. Who is going to tune these alerts so that we have a high signal-to-noise ratio here? How are we going to get notifications? How are we going to get notifications when something happens? Is that going to go into an email, right, which Guard Duty supports through SNS? Or do we want to move that into an IT service management tool? Does that need to go into our ServiceNow or something like that? So think about what you're going to do with these findings. One of the other reasons that I think is that Guard Duty is becoming more capable is that its service coverage keeps increasing. So they recently released the ability for this to do malware protection for EC2, automated and on demand recently. It can also protect RDS databases using their Aurora engine, their Kubernetes service. It can observe user and app activity. It's looking at activity in S3, and then even recently in Lambda network activity. So Guard Duty is becoming a comprehensive threat detection service, and it's something that we should definitely be using in AWS. So we've found a alert. We've got some potential for a threat. How do I investigate that? Well, my next best practice is that you should be prepared to query your logs. So CloudTrail is the primary logging service in AWS. It will tell you, a comprehensive list of all the actions people took, but it doesn't by itself provide a great way of querying those logs. You can look at recent logs in the event history in the console, and you can filter them by a single dimension, right? You can say, give me all the events that match this event name, like console login. Tell me all the console logins. But what you can't do is you can't say, tell me all of the S3 actions that this user took, because now that's 2 dimensions. So you're going to want to do that when it comes time for a real investigation, and that needs to be set up before you need to do the investigation. So some of the AWS options here are using CloudWatch logs, where you can send your CloudTrail logs into CloudWatch, and now you can filter using the CloudWatch logs query language. You can also set metric alarms for the risks that we talked about earlier, and that works. It gets a little expensive to keep everything in CloudWatch logs, especially if you want to keep them for a longer period of time, but it works. The newer capability is CloudTrail Lake, which is essentially a front end to Amazon Athena, where you're using basically SQL queries against your CloudTrail data. And one of the nice benefits of that is that it includes a number of prepared queries for things that you might want to investigate. So that's a quick way to get set up with being able to query your CloudTrail logs. And then one of the other services that sits alongside this is Security Lake. And unfortunately, Security Lake takes a lot more setup. but it overcomes the main limitation of CloudTrail Lake, which is that you can really only put CloudTrail logs in CloudTrail Lake. So if you also want to see application logs or some sort of network flow log, you will need to set up your own security data lake. So they give that capability, but that will take a lot more deliberate setup. And then, of course, you have the option of using third-party SIEMs, which pretty much all will integrate well with CloudTrail and the different AWS cloud log sources. But think about what your team will do to query those. Okay. Let's move on to this next one. So enforcing IMDS version 2. So the story here is that EC2 instances can request some data about themselves from an internal endpoint within AWS. And the original version of this, AWS doesn't consider insecure, but it doesn't do a great job of providing defense in depth against applications with vulnerabilities like server-side request forgery or issues with web application firewalls or misconfigured reverse proxies. It's something where an attacker may be able to trick your application into querying that endpoint. Because if they can do that, then they can pull the credentials from that instance. And that instance may have the ability to read and write to S3 or talk to other instances or do any number of other things. And I often see that those permissions are very broad given to instances. So I strongly recommend that you use the new version 2 of this metadata service and not just use it, but require it. And so you can set it as the default on the Amazon machine image for your EC2 instances, and you can enforce it through service control policies. So you can say, across my org, do not allow anybody to create a new instance unless this is required. And don't allow anybody to disable this. Don't allow anybody to connect to an instance unless they are using version 2, right? Before you do this, you probably want to make sure that there's no usage of version 1 across your org so you don't break anything. But once you've done that, I strongly recommend that you enforce this, and it is probably one of the biggest threat vectors in AWS that people don't think about very much. So I advocate enforcing this in your org. So in summary, we talked about a number of things today, and we tried to look at the specifics of how to do these in AWS. But I do want to take a step back and just let you know that what we really want to be doing is thinking about these questions, right? So as security practitioners, we want to ask ourselves, how will we divide roles and ensure comprehensive coverage of responsibilities, right? And that is the cloud operating model. So who's going to look at costs? Who is going to prepare for incident investigation and response? Who is going to prepare evidence for compliance purposes, right? Making sure that we have all the controls in place all the time. How are we going to maintain segmented network zones, right? As we expand and evolve, how are we going to address that? How are we going to safely and reliably deploy our workloads, right? Like what tools are we going to use? What approaches are we going to use? Are we going to use just one, or can we allow multiple in our environment and we're comfortable with that? How will we provide access and maintain least privilege, right? Like on what frequency are we going to review access and revoke unused access? How are we going to give people the ability to request access as needed so that they can do their work, but we're not giving everybody broad admin? How are we going to safely access our compute instances? So this is systems manager, right? That's my recommendation. You may have other options, but come up with a plan for that. And then how are we going to protect our important data, right? So backups, but also how are we going to protect those backups? How are we going to make sure they are immutable and segmented? How are we going to know if risky actions are taken? I can't just rely on somebody noticing something is wrong. We want alerts when risky actions are taken. We want guard duty to alert if somebody's misusing our resources, right? And we want to be prepared to investigate suspicious activity. How are we going to do that? What's going to be our approach? Almost all of these things you can prepare an exercise for, right? And say, okay, today we are going to test our capability to respond to something, and have somebody trigger an alert, have us pull up our logs, investigate them, respond, right, and go through that whole life cycle to make sure that we're doing it appropriately. Every single time that you see a post-mortem for a security incident, they will say that they did not do that exercise and actually test their plan. I mean, almost 100% of the time, right? They'll say, we thought we had a plan for backups, but those backups were not accessible, or they didn't have the right retention period. We didn't know how to restore from them because we had changed our procedures. We didn't know how to investigate suspicious actions. You'll see the public, the PR release that says, we have no evidence that customer data was accessed. Well, hold on. Does that mean that the customer data wasn't accessed? Or does that mean that you just didn't log access to customer data, right? So you want to make sure that you are prepared to answer those questions, and you have specific processes, people and technologies prepared for all of those things. So those are my thoughts on the top 10 modern best practices, and I am excited to answer any questions that the audience has for me today.
Okay, great job, Stephen. We do have some audience questions, but before we get to those, I'd like to remind the audience that we can take questions up until about 5 minutes to the top of the hour in order to give you a short break before the next session. So please send them on in now. Just go to your console, Q&A portion of the console, and type in a question for Stephen to answer. And now let's get to those questions. Let's go first come, first serve. So Stephen, if you want to follow along in the Q&A console, I'm just going to be reading the questions from the bottom up. So first one, should we be using Security Hub?
Oh, that is a really good question. Security Hub is one of the things that, just on its face and just on its name, it sounds like we should all be using it. And there's certainly value to it. But my response is that Security Hub has a number of checks built in that may or may not apply to you. And it's honestly my preference to be much more selective with the checks that I enable in my environment. For one, cost. I mean, I pay a couple dollars every month for each one of those in every region. But also, I really want to be careful about what controls I'm applying. So one of the common ones in Security Hub is that it wants you to use hardware MFA for root users. And hardware MFA is great. I use YubiKeys, and I think that they're super useful. But I have been in organizations where we prefer to use virtual MFA, and we have secure ways of locking that down. And so I don't want an alert telling me to use hardware MFA, right? And so I don't use that pack necessarily. Security Hub will also include a number of checks for services that I might not be using, right? Like I might not be using Glue, and I don't want checks for how Glue is being secured. I don't want to pay for that. But the good news is that Security Hub is just turning on particular config rules. So you can turn on those config rules that apply to you specifically. And I think that improves the signal to noise ratio. But if you're not going to go to that level of effort, then Security Hub is a great starting point. So I hope that helps. The other thing that I do use it for is I integrate guard duty into Security Hub so that I can have a workflow for suppressing findings and responding to findings, which is a capability guard duty doesn't innately have. It has to be integrated with the Security Hub, so I can then say, hey, when was this responded to and resolved? And I think that that's really worthwhile.
Okay. Very great and detailed answer. Let's see how you do with this next question. How can I ensure my environment meets specific compliance requirements?
Yeah, compliance is a good question because many customers approach security from the lens of compliance. And that's not wrong, right? But I think we want to remember that compliance and security have some overlap, but focus on different things. But if you are concerned with your environment meeting specific compliance requirements, what I recommend doing is taking a good look at what your requirements are and finding appropriate guides that match how to do that, right? So AWS has a great guide on how to ensure that PCI you are PCI compliant in AWS. But I will caution that you should remember that it's not just the AWS platform that you need to have right. So you need to go to a deeper level than that. And I think that generally you should partner with somebody who's an expert in that. That's something that ScaleSec does, and we'd be happy to help you. But of course, you don't have to use us. But when you come looking at something like PCI, it's not just that my database needs to be encrypted, right, in AWS, but have I tokenized the data within the database? Does my database have role-based access enabled? So go to that level of depth, and you'll often find that many of the controls you maybe thought you need, you don't need because the requirement does not strictly require that. But there are things that you will want to apply to your specific sensitive data or your specific compliance requirement. So unfortunately, I don't have a quick answer that'll get you compliant, but definitely connect with a partner that knows that compliance framework and take a good look at it and kind of challenge your assumptions along the way. That's my answer.
Okay, great. A quick reminder to the audience, please send in any questions you have. We have plenty of time, and Stephen lives and breathes this stuff. So this is a great opportunity for you to get some expert one-on-one discourse. All right, let's move smartly forward to the next question. Do you recommend Control Tower for new environments?
Oh, that's a good question. So AWS Control Tower is a service that automates a few things. So in particular, it automates using AWS config for configuration history and inventory management. It also automates some service control policies and config rules to either block or detect insecure configurations. But there are some other capabilities in it that I'm not a huge fan of. Like it can create VPC networks for you that I have not had great success using that automation. But in general, Control Tower doesn't do anything that you can't do by yourself. And when I build new environments, I prefer to just do those directly myself. So I won't necessarily use Control Tower. I would say I'm still optimistic that Control Tower is improving, and I may be proven wrong here in the future. But I don't necessarily think I would use it unless if you have the ability to set up those things correctly yourself. So, in short, no.
Okay, that takes care of Control Tower. Let's move on to guard duty. Is guard duty worth the cost?
That's a good question. Guard duty does have costs associated, and when you turn it on, especially if you turn it on across an existing organization, you want to be prepared to not be shocked by the kind of sudden increase in your bill. But I do think that it's worth the cost because its signal-to-noise ratio is much higher than other things. It's going to find issues that other things just don't have the insight into, right? Like other tools will not have the ability to see your AWS DNS logs, right? Like they're not available. And so I do think that it's worth it. But what I really recommend is starting your new org with it and then having, and then gradually tuning your findings over time so that you never, if you turn it on one day, like a couple weeks later, once it adjusts to your environment, it'll give you a bunch of alerts. And then that can be kind of shocking. If you instead start it when you're small and let it build up and kind of tune it along the way, then you won't have any big shock unless there's a real issue to investigate. So I do think that it's worth the cost. Not everything in AWS is, but that one I think is appropriate for almost every environment doing anything important in AWS. Yeah.
Okay, great. Let's turn to backups. How to protect my backups in AWS.
So we talked about backups a little bit earlier, and I think the main thing to think about is where is your important data, right, that you actually want to back up, because you don't necessarily need to back up everything. And start by resource tags on that data so that you know, hey, this is important, right? So come up with some sort of tag policy that says I'm backing up this data, because it's a PCI requirement or because it's production data, whatever it is, and make a good plan for your retention periods. I tend to make plans that have cascading retention, so it'll save hourly backups for 3 days, and then daily backups for a week, and weekly backups for 3 months, something like that you think is appropriate for your objectives. And then just making sure that those can't be accidentally deleted, but they can be restored from when you need them, right? Because when the time comes, it's really important that you can quickly initiate a backup, and that doesn't take 3 days for you to figure out how to do it. So think through the whole process, and do an exercise, right? Actually do a restore and see what that process looked like. And do your best to lock down IAM actions to only those required so that people aren't messing with your backups. Yeah.
All right. Next question reads, how to detect EC2 launches to mitigate the risk of cloud cryptojacking?
Yeah, so this is one of the major concerns that people have, right, is that somebody can spin up big EC2 instances, mine a bunch of crypto coins, and even if they get away with it for 24 hours, that can cost you a bunch of money. The answer is, first, Guard Duty is really good at detecting that, right? So it will detect it, and so that's one of the reasons you should have it on and be prepared to respond. But the other thing to do is just to use a service control policy that will deny launching instances of types that you don't expect to use. And you honestly just might deny almost all of the types until you decide, okay, we're going to use these types, and then go and remove those from the policy when it's time. Because there's a bunch of big ones that you have no need to use that somebody is going to use. So just block those. And so even if somebody gets access, they won't be able to launch them, or they'll only be able to launch tiny instances, and it won't be worth it. So that's one of the big things. But of course, in general, the most important thing to do is to stop them from getting access to your environment in general, and that comes down to identity and access management. So that's why I'm a big advocate of access kind of request and approval workflows, because I don't ever really want the ability to launch an instance at all unless it's going through my pipeline, right? So if I have a reason to do that outside of our established pipeline, then I can submit a request, and somebody, even if it's just a peer on my team, somebody else would have to approve it to give me that permission before I can do it, which means that if I'm compromised, my coworker is going to go, what? Why do you need to launch that crazy instance, right? And then it'll get caught. So that's my best recommendation for preventing that issue.
All right. Well, let's try to squeeze in one more question before our session break. This question reads, what security capabilities does AWS not cover so well right now?
That's a good question. Of course, AWS loves to tell you that they've got everything for every possible situation, right? That's one of the reasons that people choose them as a vendor. My answer to this question would have been different even a year ago because they've been closing these gaps pretty quickly. One of the ones that really stood out was network firewalls. If you want to have an egress firewall, a lot of people have been putting a Palo Alto firewall or something like that, some third-party vendor, and routing all their traffic through it on big EC2 instances. Now AWS provides a network firewall service that can even do TLS inspection if that's what you require. Its feature set is still not as rich as the third-party vendors who have been doing this on-prem for a long, long time. So that's something that you might not choose AWS for if that's a really important capability for you. One of the other ones is like a SIEM. AWS provides CloudTrail Lake, as we talked about, for querying CloudTrail. It provides Security Lake if you really want to kind of build your own SIEM on top of that, but that's a whole engineering effort. But that's something that, aside from GuardDuty, AWS does not provide a great way of integrating all your logs into some system for detecting threats. And that's where you're probably going to look to a third party, whether that's, Splunk or, there's many vendors in that space. But if you really need a robust SIEM that can cover many things, unfortunately, AWS doesn't offer one yet. I'm hoping that they will announce a good one soon. One of the other things that you can look at, if that's a concern for you, is they do have their OpenSearch service, and it includes a security analytics dashboard that can do SIEM-type capabilities. OpenSearch can be expensive, and it can get bogged down if it's got tons of data, but AWS does provide a number of options in that space, but unfortunately, nothing's going to compete with a full-featured SIEM in that space. So yeah, those are the two things I think they don't cover well: is network firewalls and SIEM.
Okay, great. Well, it looks like that's all the questions we have time for. So thanks again, Stephen, for a great presentation and answering all those questions.
Yeah, thank you so much for having me today. This is a pleasure to be here. I want to invite any of our listeners. I will be at AWS Reinforce, the security conference next month. If any of our listeners are there and they want to continue the conversation, I'd love to meet up and talk about it.